Now, if n is greater than or equal to 30, our sample size, and that will make n times p greater than or equal to 15, and n times 1 minus p greater than or equal to 15 for p equal 0.5. So that means that we can approximate here with a normal distribution. So in that case, we can modify our large sample sign test. So the test requirements here are going to be, again, sample is randomly selected from continuous probability distribution. Same setup for the null and alternative hypothesis for one tail and two tail. But now our test statistic is going to be that value s minus 0.5. That's a continuity correction. And then you subtract off 0.5n and divide by 0.5 times square root of n. And this 0.5n, that is half of the sample size. And then this is actually the standard deviation for the distribution simplified, that expression simplified. So this is test statistic minus the mean of the distribution, 0.5n, and then the standard deviation in the denominator. This simplifies to 0.5 root n, with p is 0.5, 1 minus p is 0.5. So, and then our rejection region is going to be z greater than z alpha. So we'll have to be given in alpha. Or if you've got two-tailed test, z greater than z alpha over 2, or less than negative z alpha over 2. Like so. So let's go ahead and carry out an example here. So Tesla is testing a new battery for its commercial truck. Previous battery had a range of 350 miles, so that's what we'll test against. We randomly sample 50 batteries, so n is 50 greater than or equal to 30, so we'll use a normal approximation. Using the new technology, and 38 of those last over 350 miles. So this is our successes. Is there evidence to conclude that the range in the new battery exceeds 350 miles at the 0.05 level? So we're going to do sign test approximation here. So we're trying to establish that the median, the middle, central tendency, eta, is greater than 350. If that is not the case, then we'll conclude that it's the same as the old battery, equals 350. So no, n is equal to 50, which is greater than or equal to 30. So that means that we'll do a large sample sign test. So our test statistic now is going to be s minus 0.5 minus 0.5n over 0.5 root n. So our n is 50, so our s then is, they told us here that 38 of them lasted over 350,000. So that's our s, that's our successes. So this will be 38 minus 0.5. And then we subtract 0.5n, so half of 50, 25. And then in the denominator, 0.5 times square root of 50. Let's go ahead and enter that into the calculator. So that's going to be 37.5 and then minus 25, which is 12.5. And we're going to divide by 0.5 times the square root of 50. So 3.54. And then we're going to reject if z is greater than z alpha. So here our alpha is 0.05. This is an upper tail test. So we're looking for z 0.05. And that you can get from the table of common z values for hypothesis tests, or you can do inverse norm of 0.95. So if we did second variables and do inverse norm, our left area is 0.95, and that's 1.645 for an upper tail test. So this 3.54 is greater than 1.645. So our Z, our test statistic, Z equals 3.54 is greater than 1.645. So that tells us that we are going to reject H0. So our conclusion will be that there is sufficient evidence for the alternative hypothesis. So sufficient evidence to conclude that the median range exceeds 350. So eta is greater than 350. So these new batteries last longer. So that is a large sample sign test for the median.